squared times x to the third. Hello folks, I'm back with homework video number 7. Again, I hope you're keeping up with your notes and keeping up with your lessons. If you read those first, the lessons that I do here will make much more sense and sink in much more quickly. Exponent rules, multiplying powers. In other words, x to the m power times x to the n power. Or you could look at that as x squared times x to the third. We're multiplying powers. X squared is 2x's, or x times x. It's not 2x, it's 2x's, x times x. X to the third is 3 more of them. So I think it seems to reason that there are now a total of 5 being multiplied together, and it makes sense that x squared times x to the third is x to the fifth. Our rule up here, the way we write it with just variables, tells us that we add the exponents, and we do. I know that sounds kind of weird, but when you think about it, it means that there are 5 of them lined up now, and so it is now x to the fifth. When you're not sure, and that's a lot when you're learning, you write it out the long way, and that helps you get to the correct answer. After you've done it for a while, it gets a little easier. Look here. 3x to the third power. Kind of like we did when there was a negative sign inside my parentheses. This 3x to the third power, 3x times 3x times 3x, there's 3 3's in there because they're all in the parentheses, and there's 3 x's. So it's 3 to the third and x to the third, and it's 27x to the third. If we go back up here and look at our rule at the top, we see that xy to the n, again using all variables, we simply say it's x to the n and y to the n. In other words, down here it was 3 to the third and also x to the third. So let's see if we can put those rules to use a bit. I got to show you one more, then we'll put them to use. Last one, what if I have x cubed, but then I have it to the third power? Well, then I have x cubed times x cubed, right? Because that means write it twice. What I see in here, I write 2 times. Well, that's like x, 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 x. So now I add the exponent. So it's x to the 6th. Now, isn't that crazy? Power to a power, or I said add. When we get to this point, we do add it. Power to a power, we actually multiply. We saw back here, then we were power on the outside, we had to bring the power inside. And we saw here where we had to add the exponent. So we added, nope, this is where we multiplied them. Okay, so you can see there's going to be a lot of little rules in here getting all messy, and we're going to have to work them out and go slow. So let's do exactly that. I will show you how to make them turn out right, and also how to get these concepts in your head so that you understand them. They'll get quicker the more you do. You need practice, right? So let's practice. X to the 5th means there's 5 x's here. 1, 2, 3, 4, 5. I'm not going to write on my little dot. X to the 3rd means there are 3 x's. So I must have x to the 1, 2, 3, 4, 5, 6, 7, 8. I added those exponents, didn't I? The 5 and the 3 got added when I multiplied. X to the 8. What do I do here? Well, I see a 4 and I see a negative exponent. Whenever I see a negative exponent, I know I want to take that thing to the bottom, and I want to make its exponent positive. The 4 doesn't have an exponent. I know it's sitting next to something with an exponent, but look, it stays up on top. So that's all you need to do with that, is show that it has the negative exponent, and instead it moves to the bottom. How about this guy? Well, I'm supposed to write what I see in here, in the parentheses, this many times. So I'm going to write 3b to the negative 5 times 3b to the negative 5 times 3b to the negative 5. Then I'm going to think, okay, that means I have a 3 times a 3 times a 3. 3 times 3 is 9 times 3 is 27. Now I have negative 5, and I could write b to the negative 1. I could write that 5 times. I'm not going to. I have 5 of them, 5 more, 5 more. I have b to the negative 15. And if I'm going to deal with negative exponents and write everything with positive exponents, 27 stays on top. Fraction bar, b to the 15th in the denominator because it's negative. When I move it down, it becomes positive, and there's my answer. How about when the 3 is on the outside? Do you notice that the only difference between this one and the one we just did is the 3's on the outside? So I'm not going to redo the whole thing. I'm going to say, okay, that 3 only happens one time. It's not going to have a 27 in the front. And b to the negative 5 to the third is b to the negative 15. If they want me to write answers without negative exponents, and they often do, they want me to move it to the bottom. And you see that my answer is almost the same, except for what I would say the coefficient, the number up front. Okay, let's tackle another one. And again, let's look at the difference between these two. I see an extra set of parentheses right here in this one. I see almost the exact same thing here. So I have a 2, and I could have 7 A's here. So 1, 2, 3, 4, 5, 6, 7. And then I have 3 B's. In the next one, I have AB, but I've got that twice. So that's AB 2 times right here. So what I have all together, I've got a 2, and I've got 7, 8, 9 A's. So A to the 9, and I have 3, 4, 5 B's. So I have B to the 5th. Let's see if we can do this one a little more quickly just by using what we did on the last one. There's only going to be one 2, right? There's no powers on that 2. We'll take something out here to get to that 2 and get power on it. A to the 7, and then look, just one more here. So A to the 8. Here, there's 3 B's and 2 more over here, and B to the 5th. See how you go slow, and they work out just fine, right? Here's a good one. This is, write this 3 times, and you'll see it's x to the 5th, x to the 5th, x to the 5th. So it's 5 x's, 5 more, it's x to the 15th. We can look back and see that, oh, we could have said 5 times 3, x to the 15th, but we're kind of going the long way, and that's all right. Here's a place where the multiplying will help you because it'll remind you negative 4 times 3 gives you r to the negative 12th, and that is the same as r 1 over r to the 12th. Ooh, lots of problems here. One more here. I just want to show that it's a 2x squared y times 2x squared y times 2x squared y. We're going to have to write it out, everything inside 3 times. That means that coefficient 2, 2 times 2 is 4, times 2 is 8. And we have 1, 2, 3, 4, 5, 6 x's, x to the 6th, and 1, 2, 3 y's, y to the 3rd. Wow, we've gotten a lot done. Something awful to the 0 power, and all I have to say about it is 1. Because as soon as I see to the 0 power, I'm done. The answer is 1. Just a little bit more practice, and we do have a couple of word problems to look at in our video demo today. Oops, lost my pen. How do we use the distributive property when we're working with exponents? Well, we multiply these two together, and when we do that, watch how we can kind of do it quickly here. 4 times 2 is 8. And we see 2 x's here, x squared, 3 more here. Altogether, I have 5 of them, x to the 5th. Then I add, and I multiply again. 4 x squared times 5 gives me 20, and just the x squared hanging out. I can't combine these two terms. I have to leave them because they are not like terms. They do not match. I have a to the 5th power and to the 2nd power. We have lots of problems on our homework that look kind of like this. We're given expressions to represent volumes, areas, and perimeters. Let's see what these do. Which expression represents the area of a rectangle with sides measuring, well, 2x, y to the 4th, and z. And the other side is 5x, y to the 4th, z to the 3rd. So they simply want us to multiply these two together. I multiply coefficients 10. I add up the x exponents. I have one here and one more here, and you think of it as x to the first and x to the first, so it's x to the second. 4 y's, 4 more y's, so I have a y to the 8th, and a z to the first, and a z to the third gives me z to the fourth, and this would represent my area if those represented the lengths of the sides of the rectangle. How about this guy where they say we know that the area of the parallelogram is 144, a to the 8th, b to the 4th. A, make that a name. And they know that the base is 8a squared b squared. They want to know, how tall is this thing? What is its height? In other words, 8a squared b squared times what would give us this 144? And another way to get the number is to say, and I could just pop up my calculator here, 144 divided by 8 is what I want, right? Let's see if I can do that. 144 divided by 8. And that gives me 18. So that tells me 18 times 8 will give me the 144. Then I say, I've got a squared, and I have a to the 8th here, so I must need 6 more of them, right? a to the 6th. I have 4 b's in my answer, and 2 of them right here, so I must need b squared. What I want to do to double check my answer is multiply these two together now and make sure that I get the area. I'm going to leave that to you. Write an expression in simplest form for the area of a circle with a radius of 6r. Oh, this reminds me, I sent you a formula sheet when you first walked in, and you can save it. It's the little reference formula sheet you get when you go to the EOC at the end of the year, the end of course state test. So you want to become very familiar with it. You want to know what's on it. And part of what's on it will help you with these questions. So you still need that, email me, but I just file transferred it. And you can go up to File and Open File for Transfer, and that will get you to the document. Save it in a place where you can look back at it all year long, please. Okay, my radius halfway across the circle is 6r. I know from the formula sheet I sent earlier that the area of a circle is equal to pi r squared. They simply want me to use 3.14 for pi, so I'll plug that in here, 3.14, and then they want 6r squared. They want me to square the radius, right? So I get 3.14, 6 squared is 36, r squared, and then multiplying 3.14 times, what was it, 36? Yes, 36 gives me 113. So let's go with 113. R squared. Awesome. Here they want us to write an expression in simplest form for the area of a triangle. Well, I wonder why I put up a rectangle. What I really need is a triangle. And again, you're going to use a formula from the formula sheet, which says that the area of a triangle is a half the base times the height of the triangle. We know that our height is, our base is 3xy. We know our height is 2y. And we know that 1/2 goes in front of it because of the formula. If I could only write 1/2. So I need 1/2. I need 3 times 2 is 6. I'm x, and I have a y here and a y here, so I have y squared. Half of 6 is 3. Not bad, right? 3x y squared. I think I'm going to do one more. I think there's one. I'm not going to do this one. I'm going to leave it to you. I think you can find volume of a box. You have a little formula sheet down here that shows you that it's the area of the base times the height, or it's length times width times height. I'm done. You can do that one. This one's a little harder, so I'll help you out a bit more. Write an expression in simplest form for the volume of a cylinder with a radius of 3w squared and a height of 2w. I went to my little formula sheet and I found that the volume of a cylinder is a big B times H. And I know, and I hope you know now, that big B stands for area of the base. And the base in our case is a circle. So we need, again, the area of the base is pi r squared, and our r is 3w squared. So from the very last slide, we learned that area of a circle was pi r squared. So we did pi times 3w squared squared. We're going to simplify that. 9w to the fourth. 3 times 3 is 9. We need 2 of them. W squared twice is w to the fourth. They ask us to use 3.14. I'm going to leave it to you to throw that in your calculator. 3.14 times 9, and whatever that answer is, which is something close to 27 point blah, 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 with w to the fourth after it. All righty, go get these problems practiced. I know they're weird at first, but I promise when you start practicing them, they feel like second nature. I also promise you're going to see them again and again, so you want them to feel comfortable. Come to TOGA with us, come to CC, get some practice in so that you're more comfortable moving forward. This is really your foundation. You need to get it really strong. All right, see you in class soon. Go practice.